Hello everyone, welcome to the Let's Get Solving with Google Cloud series. My name is Srinivas Makam. I'm a customer engineer focusing on application modernization within the Google Cloud team. This is the first in a four-part series on Kubernetes and Google Kubernetes Engine. In the first part, we will talk about how do we convert an application running in a virtual machine to a container running in Google Kubernetes Engine. And that is going to be the focus of this particular lab session. In the follow-up session in this series, we'll talk about container security, how do we do monitoring and logging in Google Kubernetes Engine, and in the last part, we will talk about how do we deploy a serverless application on top of Google Kubernetes Engine. So before we get started, I want to spend some time, talking about the fundamentals of containers and Kubernetes. I'm pretty sure you're all, pretty familiar with it. It's good to set that baseline before we get started with the lab. What is a container, right? A container is a sandbox which packages your applications and libraries in a medium and which makes it very easily portable. And portability is one of the big advantages with containers. Say you build a container in your local machine and you can run it anywhere, right? Whether it is on-prem or cloud. And that kind of a decoupling makes containers very powerful. In addition to it, the features like, a container, doesn't need an operating system. It basically shares the same kernel, makes it very fast and agile. And you can run, lots and lots of containers in a single bare metal or a virtual machine. Another key advantage with containers is the immutability aspect, where once you deploy a container and you want to do an upgrade, you basically destroy the container and redeploy a new container. So which makes it kind of very clean from a deployment perspective. In addition to it, there are other aspects like faster development, faster deployment. All these things kind of makes containers very attractive. And Docker has become the kind of the de facto runtime with containers currently. Now that we have containers, right, when we operate containers at scale, we need a way in which we want to orchestrate these containers, and that is where Kubernetes comes in. Kubernetes provides an orchestration platform which kind of decouples your infrastructure with the application. And it has not a lot of nice platform capabilities like say auto scaling. For example, if you deploy your containers on Kubernetes, you don't need to worry about how much of resources you need to pre-provision. So basically Kubernetes would look at your consumption and automatically scale the infrastructure and scale up or scale down, right, based on your need. And the next capability is about auto healing, right, where let's say for example you have your application running and a lot of things can go wrong, right? Your infrastructure can go wrong, your application can crash, but you do not want your end users to see an impact because of all these reasons, right? And Kubernetes with its auto healing capability hides all the complexity from the end user. In addition to it, things like automated rollout and rollbacks, right, where Kubernetes provides a lot of deployment patterns like canary pattern, blue-green pattern, so you can exactly control the way in which you want your upgrade to happen. All these set of capabilities, right, kind of come in the cloud native umbrella where you are you can kind of develop using modern design patterns. The most important aspect from a Kubernetes perspective is the fact that it is open source. And that basically provides like a wide ecosystem around Kubernetes. So now we have talked about Kubernetes, right? Where does Google Kubernetes Engine comes in? Google Kubernetes Engine is a managed service built on top of Kubernetes, which handles a lot of the things around the infrastructure part, and tying it with along with the Google Kubernetes Google features, Google Cloud features actually. And when the user deploys on top of Google Kubernetes Engine, they don't need to worry about the Kubernetes complexity associated with it. So now that we have covered the basics, let's jump right into the lab. So the lab that we're going to cover here is, as I said, we are going to convert an application from a virtual machine to a container running in Google Kubernetes Engine. So this is the link to the particular lab, and this is a QR code associated with this lab. It's very important you use this particular QR code because once you use this QR code and finish this specific lab, you will be able to get a 1-month free trial where you can run any of the labs within the Quicklabs environment. So that is pretty powerful. So what is a Quicklabs, right? Quicklabs is pretty much like a sandbox with a Google Cloud environment set up already for a particular use case actually. And you don't need to worry about setting a billing account, setting a project. Everything is kind of pre-created for you. So when you open up this particular lab, this is what you're going to get. This is the specific lab which is called as migrating to GKE containers. This is what we'll be running through. So the first thing we will do is we will start this lab. And this is going to give us basically a username and a password and a Google project ID. So now what we're going to do is we'll open an incognito window where we are going to run this particular project in. And why an incognito window? Because let's say you have an account associated and there are multiple accounts, it gets confusing. So it is always better to run Quicklabs in an incognito window. So I already have an incognito window opened up. So let me go there. Okay, so first what we will do is we will log in inside the Quicklabs using the account that we generated earlier. Right, so we will accept few of the initial dialog boxes. And there are some terms and conditions. So once we accept all these things, it will land us into the familiar Google Cloud console window. And then we will select the project. Right, let's make the font a little bigger. Okay, so now that we have kind of logged into the project, so now let's basically look at the CloudShell. So CloudShell is a VM that is set up by the Google Cloud, which already has the Google Cloud tools pre-installed. Okay, so now let's make this shell pretty wider. Okay, let's make this font a little bigger. Okay, let's open 2 more terminal windows because we might have to execute multiple things. Right, now that this is done, let's look at what project is set in the environment variable. So we see that our Quicklab project is set up here, so that is good. So before I go into the detail about what this particular Quicklabs is going to do, I want to start a script which is a Terraform script which sets up all the environment, and then I will explain what this particular lab is going to do. So one more thing that I need to do is open up the code editor window. So let me open that up, and that is going to be our IDE for looking at the code and doing all the development. So let's have the IDE up and ready. And once the IDE opens up, let's also make the font a little bigger here. Okay, so the IDE has opened up. Okay, so what we do is let's go back to the CloudShell and let me basically now run through the script that is needed to start set up the environment. Okay, so first what I'm going to do is install Apache Workbench. Apache Workbench is, we are going to use Apache Workbench to generate traffic to the configurations. It's basically a traffic generator, that's what it is. So that is, we're going to use it to simulate traffic for our use case that we are going to set up. So now Apache Workbench is installed. I have that going. Next, what we will do is clone the repository that has all the environment that is necessary to create this particular lab. Okay, once I cloned it, then I will set the regions and set the directory. So here I am setting the region and zone to Central 1A. One other thing I need to do in the script is my default mission type. I need to change that. So let me change that as my next thing. And for that, I will go to my my workspace here. So, and then I will go to my Terraform directory, and in my variables.tf, I'm going to change my instance type from F1 micro to N1 standard 1. And let me save that. Okay, once I have done that, the last thing I'm going to do is start the script that is going to set up the environment. So let me start the script, and this is going to take around 7 to 10 minutes. While this is going through, I'll walk through what exactly the script is doing, what the lab is doing, and everything actually. So first, let's go to the lab, and let me explain to you what this lab is specifically doing. All right, so this is the specific lab that we are interested in. So this lab creates 3 environments actually. The first environment is it creates a Debian virtual machine and runs a Python Flask application on top of it. Let's look here what this particular Python Flask application is going to do. It's going to do 2 very simple things. First is it's going to find the factorial when you give an input number, and the second is it is going to calculate the sum of the prime numbers when you give an input prime number. That's all it's going to do. It's a very simple application, but the whole point here is to kind of go through the workflow of how we can build and deploy the application, right? So that is primarily what we are trying to do here. So now, as I said, right, the first configuration that we're going to have here is basically a Debian virtual machine on top of which we're going to deploy the Python Flask application. The second configuration that we're going to deal here is that we're going to have a virtual machine which runs a container operating system, on top of which we are going to build a container using the Python Flask application and deploy the Docker container directly on top of the container operating system or on top of the VM. So that is the configuration we're going to do. And in the third configuration, where we're going to use Google Kubernetes engine, we're going to use the same container that we have built on the Python Flask and deploy that container using pod, services, and ingress on top of the Kubernetes cluster that we have created. And we will also do a few more things on top of it. We will basically try to generate load and see that how the application behaves, and we will try to do an auto scaling and see that how the application behaves based on the traffic load. Okay, so now that I've explained what this particular project is going to do, let me jump back to my project where things are going on. Okay, it's still running through the different steps. In the meantime, what we will do is we will first look at the environment itself that we have set up, right? So I initially showed you the variables.tf, and these are some of the Terraform related stuff. But before I start, let me first start with the source code. I think the most important thing for this whole thing is where am I building this application from, right? So here, if I look at the source code, this is my Flask application. So if you look at it again, it's very straightforward. There are 2 endpoints here. One is a factorial endpoint and there is a prime endpoint, and this is going to calculate the factorial, and this is going to calculate the sum of the prime numbers, right? And that's all this particular application is going to do. And now once I have my source code, I need to build a container out of it. So now if I look at my Docker file, so inside that Docker file, I have a source, base container, which is I call it as a Python 3.7, and then I add some labels. Then what I'm doing is copying my source code inside the container and creating a user who will be the one who will be running this container. And I've also sent an entry point so that this web server will start up when my container is spun up. So that's what the Docker file is do. So first we looked at the source code, we looked at the Docker file. This is what is going to build the container. Now what is actually going to trigger the building of the container? And that is what the cloud build is going to do. So what the cloud build is going to do is very simple. Whenever you make a change to the source code or to the Docker file, it's going to take the files from there, build a container out of it, and push it to the Google container registry. And by the way, cloud build is a managed service available inside the GCP. Okay, so now we have talked about how do we build a container image. The last part we will look at is how is my, the Kubernetes manifests that are present for, running my application on top of Kubernetes. The first thing we look at is the deployment file. So in the deployment file, what we see is it's a prime server deployment, which is going to use the container image, which is that one that cloud built it. And I'm saying, use replica count of 1. And I'm saying expose this particular, pod on port 8080. And it has a liveness probe and a readiness probe also present, which is, directly the slash endpoint that is, present in that particular pod. Then I have a service defined on top of that. Inside the service, what I'm specifying is that use a selector of prime server, expose it on port 8080, and the service is of type node port. And the last thing I'm going to define is the ingress. Inside the ingress, what I'm saying is, by the way, ingress is a controller that is responsible for exposing the service to the outside world. In the case of GKE, when we have an ingress, it creates automatically a Google Cloud load balancer with the appropriate configurations that is present in ingress and points it to the backend service. In this case, it will be a node port service. Okay, so now that we have looked at how the Kubernetes manifest files are there, let's look at our script, right, where it is now. Okay, the script has done a whole bunch of things. It has created a bunch of servers, bunch of VMs, and then it has also created a Kubernetes cluster, and now it is waiting for the Kubernetes cluster endpoint to be healthy. Okay, so while this is happening, let's look at the one of the endpoints, which is basically the web server, which is the VM endpoint. But before that, I want to show you inside the Google console what is happening. That will be interesting. So let's first look at what are the compute instances that are created, right? Make it a little bigger. Okay, and what we see here, there are 4 VM instances that I've got created. One is a VM web server, which is basically the Debian VM. And then we have a COS VM, which is a container operating system VM on which we are going to deploy the Docker image. And then we have 2 VM instances. These are the worker nodes that are part of the Kubernetes cluster, right? So now let's go and look at the Kubernetes cluster itself. So go to Kubernetes engine clusters. All right, so here I see that there is one cluster that is created with 2 nodes. Let's look inside the cluster. All right, so let's go there. Okay, so we see a bunch of parameters. This is a version 1.16. This is the API server endpoint, and you will see all the configurations associated with networking, security, other features, everything associated, right? Main thing that we're interested in is in the default node pool, where I have 2 nodes created. Then if I look under the workloads, I can see that there is one deployment that I have done, and as I have said earlier, there is one replica, which means one pod. And if I go and look inside my deployment, I will see that I have that one pod that is actively running. Okay, so now we have looked at the Kubernetes cluster. Let's go back to our CloudShell. The script is still running, but in the meantime, let's try to access our endpoint. So let's access one of the endpoints here. So basically, this is the endpoint associated with the VM web server. So now here, let me access my factorial service endpoint, and let's say I want to access the factorial of 20. So this is my factorial of 20, and then let me try to access my prime of 15. So it's going to tell me the sum of all the prime numbers, right? So this is basically I just showing that in my VM endpoint is working fine. Let's go back to the Cloud End Shell, and now what we will also do. Okay, we just got our service to be up now. So let's basically also look at our the virtual machines, right, that we created. So let's go back here and log into the VM web server, and there's an empty passphrase. That's fine. Okay, so now that we have logged into the VM, so let's look at the what processes that is associated with the Flask that is running. Go back up. So we see that there are, two processes that are running directly on the machine, right? And that is the endpoint that we accessed earlier. Now, what we will also do is that we will access the cost VM now, and we will look at the container that is running inside that. To do that, first let me log into my cost VM, and this is my cost VM that I'm logging in, which is in zone US Central 1A. Okay, I've logged in here. First, let me look at my docker ps command. So here you can see that the prime flask container that we have built is running as a container inside this particular node. Now, if I look at the processes, that will be interesting. So here, whatever we see as the process is not actually running directly on the virtual machine. It is actually running inside the container, and those processes are mapped to the host machine, and that is what we are seeing here. Okay, so now we have seen two things, right? We have seen the VM configuration, we have seen the container operating system configuration, where you have the container running inside the VM. Okay, now we'll go to the Kubernetes environment. That's the one we are more interested in. So first thing what we will do is we will basically log in with the cluster here. So I will use my central 1A. Okay, so I've logged in, basically I fetched the credentials. So now I can directly talk to the cluster. So let's me look at the nodes. Okay, so those are the two nodes. Let me look at my deployment, and this is same as what we looked into the the GCP console earlier, right? Nothing different. The main thing is, let's look at the ingress. It's a typo here. Okay, let's look at the ingress, and this basically is the endpoint, which is a Google Cloud Load Balancer endpoint. Let's try to access my Google Cloud Load Balancer endpoint, and I can do the same as I can access my prime endpoint inside that, right? So, and that is working fine. Now let's go back. Okay, so now we have accessed our prime endpoint from within. So basically this endpoint comes from the Kubernetes cluster. What we will do is we'll generate some traffic load now, and see that how the Kubernetes cluster behaves, right? Okay, so I'm going to use Apache Traffic Bench to generate the load. Remember that when we started this project, we installed Apache Traffic Bench on my CloudShell, and make sure it's still running. So let me go here, and in here what I am going to do is use the IP address of my Kubernetes ingress service. Basically, it's directly going to hit the load balancer. So let me give that endpoint here, and we start it. So what this is going to do is it's going to send 120 concurrent requests for a time period of 60 seconds, and it's going to tell me the number of requests that are successful and the number of failures, right, associated with this. Remember, at this point we have only one pod running because we specified only one replica when we started the deployment. So this traffic test is running. It's going to take some time. Let's go to the Google Cloud Console. Let's look at the workloads, and I think we should see that some amount of traffic that should come up. And I think that we should see a little bit of CPU usage that we can see at this point. Okay, and since we have only one replica, and I can show you that there's only one replica running, let's go back to the CloudShell. So it has already completed 5,000 requests. Okay, it's done now. It basically was able to process 7,500 requests with one replica. Now in this case, because I've hard-coded the number of replicas, it's not going to kind of expand. From a testing perspective, what we will do now is increase the replica, that how it behaves. Okay, so what I'm going to do now is I'm going to increase the replica count to 5, and let it do increase it. So let me now look at the pods. Okay, so basically it's creating the containers, me look at the deployment. Okay, 5, it's still not yet up and ready. So wait for some time for it to come up and ready. Okay, coming up. So once this is okay, it's 5 out of 5, right? Okay, now everything is up. Now what we can do is run the traffic Apache traffic bench test, the same test that we ran earlier, right? So it's going to run for some time, and in the meantime, what we will do is we will look at the in the console what is coming up here. Okay, we see that 5 pods we have scaled, and we can see all the 5 pods coming up. I can even go to individual pod and look at what is my CPU and the memory usage. I see already a spike coming up because of the traffic load. It decreased and now it will again increase. Now one of the things that what we have done is initially we started with a static replica count of 1, and then now what we have done is we have increased the replica count into 5, but this is still a manual process. So the right way to do this is set up something called as a horizontal pod autoscaler inside the Kubernetes deployment. What it will do is it will look at the traffic load that is coming into the pod and automatically scale the pods up when there is more load, and low when when there is lesser load. Actually, I've not done it just because we have lesser time, so I did not do the horizontal pod autoscaler, but it is pretty simple to set it up actually. So now if you look at it, with 5 replicas, my request count is around 12,058 actually. If you remember earlier, with 1 replica, it was around 7,000 and odd was the number of requests that it could handle actually. So basically what I wanted to show was with Kubernetes, it is easier to do the scaling, and the scaling can be either static or the scaling can be dynamic if you have the autoscaler enabled. And that is the flexibility that kind of Kubernetes gives us actually. And that is pretty much kind of what I wanted to show in this lab. Let me go back to the slides and I will try to summarize what we have kind of talked till now. So let me go back. Okay, so basically this is the specific lab. By the way, so this is the specific lab we started, and I think you can also try the same lab as I walked through today. And if you go back, and this is the QR code associated with this, and please try this lab. One last time, let me summarize what I did. So basically I created 3 environments. The first environment, I created a VM and I directly ran the application on top of it. In the second configuration, basically I have a container operating system VM on top of which I deployed a Docker container, and I was able to serve the endpoint. In the last configuration, I created a Kubernetes cluster and deployed the container with 1 replica to start with, a pod with 1 replica to start with, and then I did a manual scaling, and I showed that when you scale up more number of pods, you're able to handle more loads. And then I also mentioned with using autoscaler, you can kind of make this dynamic. So that is pretty much what I kind of wanted to show in this specific lab. I'm hoping you would kind of run through this lab, and we will continue to do this next set of sessions in Kubernetes and GKE. Thanks for participating in this session with me. Bye.